All right, let's start chapter 27, which deals with water, electrolyte, and acid-base balance. So let's first off take a look at body fluids. Now, females are about 52% water by mass, and males are about 60 to 63% water by mass. And the reason for the difference is that females typically have more adipose tissue, and adipose tissue is only about 20% water, where muscle is mostly water, 65% water, and so that's why we see the differences. We look at fluid compartments. Fluid compartments are where we put fluids, water in our body. One is the intracellular fluid compartment. So intra means within, or the IFC. So the intracellular fluid compartment, or IFC, that is fluid within cells. And this is most of our water that we have in our body, about 63% of that water. Next is the extracellular fluid compartment, or EFC, so extra, outside. So this is fluid outside of the cells. And this is about 37% of the water that we have in our body. So most of our water is actually found within cells, not outside of the cells. Now, of that water that's found outside of the cells, we have interstitial fluid. Now, interstitial fluid is fluid within tissue spaces, so it's between the cells. And this is about 80% of that extracellular fluid. So the other 20% is found in plasma and lymph, so kind of a small amount of fluid that we have in our plasma and lymph there. Now, we look at the composition of body fluids. We have electrolytes, and electrolytes are molecules that will dissociate in a solution, forming ions. And they can conduct an electrical current with it when they're dissolved in water. So most salts are electrolytes, acids and bases are also electrolytes. So, when you see stuff forming these ions, it was once an electrolyte. Non-electrolytes are molecules that do not dissociate in a solution. So they do not form ions. These guys are made by covalent bonding, or electrolytes are made by ionic bonding. All right. So a lot of things are non-electrolytes, like glucose and lipids, urea, stuff like that. Now, when you take like sodium chloride and you put it into water, so that is an electrolyte, it will separate into sodium ions and chloride ions. All right. Now, if you take glucose, which is a non-electrolyte, and you put it into water, well, it still stays glucose. And so because of this, electrolytes have more of an ability to cause fluid shifts than non-electrolytes. So if you take sodium chloride, which is together as a salt, and you put it into water, it separates into sodium ions and chloride ions, which I already said, but that is essentially two dissolved substances now, where glucose remains as one dissolved solids. So that's why water will shift where that sodium chloride is more than they will to just the glucose. All right, so let's look at fluid movements. So one is exchange between the plasma and the interstitial fluid. So here, high hydrostatic pressure is going to force fluid from the plasma into the interstitial fluids, and we talked about that in previous chapters. Now, osmotic pressures, so dissolved substances in those fluids, are going to move fluids from the interstitial tissue back into the plasma. All right, so that's typically caused by plasma proteins. Now, if we look at exchange between interstitial fluid and intracellular fluid, that is all by osmosis. All right, now let's take a look at water balance. So water balance equals water output, water intake equaling water output. So if we look at water intake, we're going to take anywhere from 1,500 to 300 milliliters per day. And 60% of that is going to be in beverages, 30% in moist foods, and 10% in metabolic water. If we look at water output, you can see, like 60% is urine, 6% or 4 to 6% is in feces, and then the rest of this is evaporation. So this could be sweat and what we call insensible evaporation. So that's evaporation just coming off your skin, off your lungs, stuff like that. So that's about 500 milliliters per day. If we look at the regulation of water intake, the driving force there for water intake is thirst. So when the body loses water, the extracellular fluid loses more water by osmosis to the intracellular fluid. And so the salivary glands get their fluid from the plasma. So if there's less fluid in the plasma, then there's less saliva that you have, so your saliva thickens. And this is going to stimulate osmoreceptors in the thirst center in the hypothalamus, and this causes a person to feel thirsty. All right? Thirst response is actually inhibited by the distension of the stomach. So when we put water into our stomach and our stomach stretches, that sends a response back to us to stop the thirst response. And this is before even the water has been ingested, because you can ingest too much water. Let's look at regulation of water output. We have insensible water losses. This is by feces and evaporation. And we have sensible water losses, like by the kidneys. All right, so we use urine to flush solids. It also eliminates excess water from there, and that's about 30 minutes after ingestion. A hormone is involved in this, antidiuretic hormone. When we release antidiuretic hormone, this causes us to conserve water in our kidneys and to excrete a concentrated urine. We'll still lose some water throughout the day in urine because we need to flush those metabolic wastes. Having excess water in us inhibits thirst and also antidiuretic hormone secretion. So by inhibiting antidiuretic hormone secretion, you'll urinate out large volumes of water. If we look at disorders, one is dehydration, and this is a condition of excessive water loss. So your water output exceeds your water input. And so this is typically when you have more than a 10% loss in water loss. So you get a sticky oral mucosa, you're thirsty, you can have dry, flushed skin, and in some cases, really bad cases, mental confusion as well. Next is edema. Edema is an abnormal accumulation of fluid in body parts or tissues. And this is going to cause swelling to occur in those tissues. This is caused by an event that either steps up fluid flow out of the blood or hinders its return. So you can have bad venous valves, you can have a localized blood vessel blockage, congestive heart failure can cause this, even high blood volume can do this. So high hydrostatic pressure is going to force fluid into those interstitial fluids. This can impair tissue function and the efficiency of the circulatory system. Another condition is called hypotonic hydration. This is a condition of overhydration. So you've taken in too much water, and so what happens here is your extracellular fluid is now has now become diluted, and this can lead to what is known as hyponatremia, which is hyponatremia. So this is an abnormally low concentrations of sodium ions in the extracellular fluid. So water moves into the cells, and so the cells will swell. This can cause nausea, vomiting, muscular cramping, and in serious cases, this can lead to cerebral edema, which can result in disorientation, convulsions, and even death. And people have died from ingesting too much water. Now, in order to do this, you have to drink a couple of gallons within like a half hour. So